Hi, and welcome to part 3 of the mini pallet project. In this part, we'll be making the mini pallet for the rotary table, and there's some interesting options here, so let's get to it. Alright, so here we are at the first step for making the mini pallet for the rotary table. First I'm going to face both sides of this. First I'm going to face the one side, flip it around, make sure it's flat, face the second side. Then I got to bore some holes through it so I can mount it to a shaft so that I can turn the outside. I mean, the outside's not critical, I just want to do it. So anyways, let's start here. Starting at 300 RPM using a aluminum cutting insert. 20,000 steps of cut. Alright, side one done, chamfered and faced. Flip it over and we're going to do the second side. So as an experiment, I decided to put a line using this profiling tool. Every ½ inch radially, every 1 inch diameter all the way out. It might help me align things. I didn't put them very deep so I can always face it off if I don't like it. So here we're going to drill and bore the center. So I'm drilling out the center of this so that I can create a plate here that will fit in, that can be held in, and I can interchange the plates if I decide how I want to locate off the center. So I'm going to try and bore this very accurately. First I'm going to drill out to ½ inch, but I'm going to go and put a 1 inch bore all the way through it with a 1½ inch relief on the top that it'll slip into. Okay, we can bore the rest. $848 thousandths. So we have to go to an inch. So, all right. So first shot, we're going to take 50 thousandths. We have 150 to go. Alright, let's get a measurement. Love it. Push the chip to the inside. All right. $9.95. Okay, we're right on target there. So, all right, let's try 4. Although these carbide cutters aren't quite as good when you, even the sharp ones, when you take really small bites like this, but let's see what we can do. Actually performing really well. All right. Alright, 2/10 over. Let's see, maybe further back. See if there's a difference. Alright, 3/10. So we're going to call this good. Now we want to do an additional 1/4 inch flat, a 1/4 inch deep. I did in the past, thought there were cameras on, forgot. We're about 1.475, so let's try 20 thousandths and see what we get. Okay, let's see where we're at. $496. All right, so right on the money. So I guess let's take the last 4 thousandths. Add some lube, stop the sticking. And I guess this time around we're going to take it to depth too. Should be right there. Let's give it one last look here. You can come back and break some corners. Okay, I call that 1.5. So now I just need to break some edges, and we can make a mandrel for this, so I can turn the outside just so it's nice and round, so I can indicate off it if I want to. Not that I think I ever will, but just in case, never hurts. I like to have everything dimensionally accurate if I can. So I'm going to relieve these edges and I'll be right back. So this next part, I'm going to make a mandrel for this that's going to fit through here that I can bolt to the front so I can turn the outside edge of this. It's not at all critical that I turn the edge of it. I just want to and make it symmetrical at the inside. I also am going to have to mount this in a 4-jaw chuck, indicate off the center, so I can counterbore the other side for the two pieces that are gonna, for the part that's gonna hold the center cap in. Anyways, so I'm gonna get started. I'm gonna face this and just turn the outside edge to make it all the same concentric, and go from there. There's more. Okay. So next we're going to skin the outside a bit, just so that we have something to grab on that's going to be concentric and repeatable. If I really needed all this to be accurate, I'd have to do this in a 4-jaw chuck and, you know, indicate it off it each time I put it in, because 3-jaw chuck's only accurate to a couple thousandths. In this case, I think 3 or 4 thousandths. Every time you take something in or out, it could be off 3 or 4 thousandths. So on this guy, I'm just turning the outside right now just to clean off the uneven surface from this being extruded. The first inch or so, or 3/4 of an inch, is going to be inch diameter with the face, and then so I only need to go back to say about here, just to give it something to clamp on that's the same each time. Still be off by a couple thousandths in the 3-jaw, but anyway, that'll be fine. It's going to be a shame is when the 3-jaw chuck bites into this beautiful surface here. That's going to hurt. And that was my sign, apparently, to stop. Nice bird's nest. All right, reposition the chuck. Fortunately, the bore of my lathe is such that I can actually fit the center of this down the middle of it. Alright, so we need to go about 3/4 of an inch down, inch in diameter post, and that'll become my spindle for turning the outer diameter of the main piece. One more thing that's kind of handy, it's going to be double purpose, so I don't mind so much, is that this turning spindle I'm going to make, when I'm done, it'll become the insert piece, I'll part it off and it'll be the insert piece that goes in here and goes down the center. And I actually need to make two of those because I'm also going to want to have one from the back to pull against. So I designed this for multiple reasons. One is on my rotary table I have an let's see, what is it? It's a Morse Taper 2 insert on the table. It sticks up with a threaded top, and I built a little piece that screws on there that'll center this right up when you put it on the table, so that all of this will be concentric with the center. And then I can screw this part down to it. So that's my goal anyways. Alright, so we're going to try some big bites this time around. I think we're going to go for see how 2/10 is going to go. Looks like it'll pick up on this just fine, because we've got a lot of material to come off. Oh, that looks like it's in there square, doesn't it? Here's an interesting little snafu, because I had you know, a bunch of this sticking back here in the chuck. I ended up having to cut it off because unless I really want to crank down on these jaws, the extra weight flying around back there that wasn't balanced was causing the front of this to wobble a bit, even as tight as I had it. And I really didn't want to have the jaws dig really deep into the aluminum, because you know, then you'd have a spot you couldn't grab on again, because you wouldn't be able to repeat it exactly. So I mean, I'm grabbing firmly but not over tight, so at least what I'm perceiving is over tight. So anyways, so we're gonna continue on here, and we're going to reduce this front diameter for an inch down to 1 inch in diameter. It'd be square if it wasn't round. Or you get my point. First go around, we're gonna try a pretty big bite and see how this works. We're gonna do 1/4 inch. Get my feed direction going the right way. Okay. That worked pretty well. Let's do that again. Let me get some of these chips over here. I could also take my feeds a lot more. Right now I'm going very slowly. I'm sure I could go forward with a bigger bite. Why don't we try that, since this is roughing passes anyways. Let's do it. So this is 9/1000ths of revolution going forward, so this should push in pretty hard. And we'll take it down to 200/1000ths just to see how that goes. Oh, actually that's fine. Wow, no problem. I know I'm not close to my inch yet, so once I start to get close, I'll come back and measure. Chip breaker's working well. This kind of feed rate. Before I overshoot my overzealousness, let's measure. I'll be right back. So we're 1.4 inches away, so 4/10 has got to come off. So why don't we get crazy and do 350, see what happens. It's a pretty big bite, but let's see what happens. So here is $350 at 0.09 per revolution. That might be a bit much because wow, that sucked. Oh, the tool holder moved. Oh, wow, that was a ton of force. Haven't taken a cut that big before. Boy, some serious welding there too. Okay, that might have been a bit aggressive. And yeah, even though my tool holder was tight, it rotated the tool holder. Here, ruined this piece, and I gotta go again. But let's see. I don't know if you can see here. Yeah, it rotated. It pushed so hard, made a conical section out of it. Well, that's how you learn, right? And I usually keep it flush on all sides to give it maximum support too. Unfortunately, the length of this does not allow the third screw to bite on it, which is very disappointing because I would always use it if I could. Alright, well, now we get to start over. That's what happens. But look at that nasty chip. Here's another one. Especially since it started biting a lot more than the 3/4 by the end. Anyways, so we're gonna have to go again because now I've ruined this. I'm gonna have to face that off and pull back a bit further. I'll be right back. Alright, so I'm back again, and we're really close now. So we the last 50 thousandths. In my overzealousness, take the really big feeds and feeds there in depth of cut. I ended up welding some aluminum on the insert that I could not get off with a scribe or anything else. So I had to rotate it, and I think if you're going to do that, you probably need to use flood coolant or something to constantly keep the lubrication there. Anyways, so we're going to hit running around the last set of cuts. Second to finishing pass, slowed the feed rate down so I get a better surface finish. There you go. That's good. Nice tight fit. Alright, so we're going to center drill this, and we're going to do 1/4 for this right now. The mandrel, the Morse taper is 3/8 24 threads, but I've got some logistics with that I need to work out before that can work. So I'm going to start with this, the 1/4 because most of the force will be put right on the flange itself rather than the screw. The screw's just to keep it on, and I will use a center to make sure the screw doesn't unthread. So when we get there, you'll see. But in the meantime, I'm going to drill and tap this 1 inch deep for 1/4. That's it. It's a number 7 drill bit to tap for 1/4. Be right back with the tap. So I'm using my spring-loaded center on the tap handle here in the chuck, and I'm going to tap 1/4 in the part. I think I'll probably follow this up with a bottoming tap just to get the maximum number of threads. Although typically having tons of threads is not necessarily advantageous, because for the most part, depending on the material, but only 4 or 5 threads are actually doing the work, and after that they're not doing anything. And if the first 4 or 5 fail, then the others will fail catastrophically. So you're not buying a whole lot. Alright, I think I just hit bottom there. So I'm going to bottom tap this and I'll be right back. Alright, so I've set this whole thing up just so I can turn this outside edge because I really hate the fact that it's uneven. So I am going to do that, and I'm going to run it at 400 RPM. Most of the weight should be on the mandrel, but I've also, so that the bolt can't possibly back out, it should tighten under the forces, but I've got a live center pushing on it rather hard so that it can't untighten, and we'll see how it goes. I'll go gently. So we're just taking 25 thousandths off the outside. That is a lot nicer than just a plain extruded finish. Oh, you would have scratched my finish. Alright, that was sort of painless. So, I'm going to add some more chamfer to the edge since I just took off part of it. Alright, so now that I've turned the outside edge of this guy, this mandrel was a one-time use thing, so now what I'm going to do is I'm going to bring it down to about 1/2 inch and then turn this outside diameter down to 1.5 inches, which is what this hole is, 1/4 inch, and then part it off so that I've got my insert for this side. Okay, wow, didn't think I'd get that. Nice fit. First try. Okay, so we just need to part it off. So we're going to need to turn this down to final dimension, but should be reasonably close right now. This needs to be a little thinner. Plus I got to take the pip off. Be right back. Alright, so we're facing this part right now, and we're trying to get it down to 1/4 inch. I'm actually going to shoot for like 1,000th under 1/4 inch, just so it sits just below the surface, so that it won't be proud, because you know, if there's dirt or something under here, I think that might be a problem. So right now we're 0.273 and we're shooting for 0.250, so that's 23 thousandths. So let's take 20 thousandths and see what we get. Of course, you want to just bunch up and scratch my beautiful finish. Why? I ask you, why? Let's measure that and see what we get. .253. I don't know if you can read that, but 0.253. So we need 3 thousandths off. This gossamer stuff's gonna want to just, yeah, bunch right up, won't you? Yeah, thanks for that. It was going so perfectly well. Okay, well, it's not terrible. Boy. Alright, so what we've got here. .249, that's right where we wanted to be. Okay, well, I'll be right back. Let's test fit this. Alright, so here's the test fit. Oh, there's some little debris down there. Alright, boy, that is a nice fit. So, we're good to go, and we'll move on to the next part, which is mounting this guy in the forge on, putting a relief in the back side to match the front side, so that we have something to hold this piece in against. So, alright, so change of plans. One more thing here. I am going to use my center just to put a pip in the middle so I can always find the center just by sight. And I've decided that I don't need to actually relieve the back of that disc and make it so that I can screw this in from the back, because this fits so perfectly that there really isn't any need to screw it in, because it's just sitting there as a flat filler plate. And it'll let me make a piece to find center using the Morse taper insert in that rotary chuck. So I'm sorry, rotary collet, neither. Rotary table. I'll get it. So anyways, I think this is about done. I'm going to leave everything as is. Alright, so next I am going to make a insert piece. This is 1-inch diameter 303 stainless. I'm going to make a piece that's similar to this, except using the 1-inch diameter of this. This is already right on. So that'll help me locate in the rotary table, it'll help me locate the center with this inserted down the center. So I just need to get a length of this cleaned up, 3/8 24 threads on it on one side, and I need to make it stick up high enough that I can just pull it out, unscrew it in place, or pull the whole thing out in place after I've got the rotary table down, put my plug in, and away we go. So this will just be an alignment tool. Alright, so I'll get right to it. So first I'm just going to face off the end here and make it square and give it a countersink. This is just the top, and then we'll cut off a section and drill and tap. Alright, so this will locate on this, and I'm going to make it so you can just pull this out after you're done and then put the plug in. So got the length right. Now I just need to cut it off, drill and tap for 3/8 24. One thing I gotta remember is that these threads don't need to be very deep, because the Morse taper threads are not very deep. Okay, so we're going to do a 3/8 24 here. Alright, so here's the test fit real quick. So the largest diameter of the Morse taper is now is 800 thousandths, so it's smaller than the 1 inch. So the chamfer I put on the edge actually makes it made up kind of nicely, makes it look like it was meant to be like this. So now we have a piece to help locate the center right here, and we'll show all this together at the end. Alright, let's move on to the drilling and tapping. So first step in finding the bolt hole is I need the bolt hole center. So each segment there, each division is 1/2 thousandth, so I'm a little bit under 1/2 thousandth out of round. So I found my center point, and now I can go and ahead and do my bolt holes, which is going to be my tapped holes. Alright, so the next step is to drill my my hole patterns that match what I've got here, and I'm actually going to have to change this one and shift it over to here or so. because what I did was I've modified the design and I've added some flats top and bottom, so that if I ever want to find orientation again and make some changes relative to my zero, I've now got flats that I can put in the vise, and I didn't lose a lot of area, so this will be fine. So what I did was, I mean, one way to do is try and figure out how to mount this on the rotary table, and then just go in this case 30-degree increments all the way around. But my DRO has a bolt hole pattern solution, so I am going to try that one instead, and we're going to drill all the holes, like I said, make slight modification to how I was going to mount it. Anyways, let's see how it works out, and we'll give it a go. Let's drill it. And what I'm using here is my deep spiral drill bit, and I think we might have some luck with drilling all the way through this without having to stop constantly. I noticed that there was a little bit of loading in the flutes, but not much, and it went really smoothly. So we'll give this a shot. So let's go to position number 2. So I kind of have a little bit of a verification here in that the holes are landing on my my bolt circle, my scribe circle, so which is pretty close. I noticed a bit of drill bit deflection initially. So from now on, it's going to be a whole lot of rinse and repeat, so I'll bring you back. Alright, so next step is just to tap the holes, and I'm going to tap all the way through. Hopefully this will work. We'll go really slowly. That's it. So we'll do the rest and I'll bring you back. So we finished tapping and drilling the outside bolt circles, and now we're going to do the next 2. So there's only 4 holes on each of these, and they're closer to the middle. And I'll be right back. Well, I'll let you see drilling the first one. What the heck? I'm sure you've seen plenty of this. So to save me time, I think I'm just going to drill and tap each one as I run across it. So here we are, jumped to the end because my camera battery died without permission, and didn't tell me it was doing so, so I lost some footage. But it was a lot more drilling and tapping, and as you can see, it's not very symmetrical pattern, and that's because the bolt hole function on the mill worked a little bit differently than I expected, and I was not smart enough to go and check all the positions before I drilled. So this is what happens when you don't check your work. So anyways, so it's not symmetrical, it'll still be very functional. Also, you didn't get to see the drilling and reaming of these two pinholes. Anyways, for a final all put together how it works and all the features I put in this, you can just jump to the next video where I just review it real quickly, both pallets. So thanks for watching. Hope to see you soon.